We're going to dive into our topic today. We're going to install Gentoo Linux on a virtual machine from scratch, effectively. Not Linux from scratch, Gentoo from scratch. So first things first now, because we're going to pivot and get hyper focused on the task at hand. So I'll be monitoring chat, but we're gonna try and stay focused on the task at hand here today. So we'll get those tips out, and then I will pivot. Hopefully, you guys can see this all right. We are looking at the Gentoo website here. So we're going to do a little demonstration today. We're going to install Gentoo. Gentoo installation is not for the faint of heart, as they like to say. It is definitely not even guided. It's not even a guided installation. It's guided if you read the guide. But the way Gentoo installs work, you basically boot up a live CD or a live instance of Gentoo in RAM on the machine that you want to install it on, and you follow the handbook on how to actually get Gentoo on that system. So looks like April 2nd they made a major upgrade to their forum. Guys, I've been using Gentoo Linux since I was 13 years old, probably. And the forums were where I got a crap ton of help. Okay, so I cut my teeth here in the Gentoo forums and also in the IRC channel. Maybe I can pull that up real quick. Let's do this. I'll show you guys the IRC channel. What are we going with? What are we going with? Tmugs attach IRSSI. Is that it? Yeah. So bear with me one moment here. Oh, wrong button. Still getting used to my new window manager here, but this is the Gentoo IRC channel. And if you're familiar with IRC, you know what I'm talking about. But if you're not familiar, it might be worth exploring. It looks like there's a giant network split. A ton of people are getting cut out of the channel here. This is typical in IRC to see a lot of people coming and going. It is probably the first chat protocol ever created, and definitely one of the most decentralized chat protocols out there. But it's old school, guys. Old school. So I hang out in the Gentoo IRC channel here on LiberaChat. You can see that down here. I'm actually connected to tantalum.libera.chat in the Gentoo channel. So that's that. Nothing else much to mention there. But we will be installing Gentoo today. Again, it's not guided. So how do you get started? Step 1, boot a live environment. Choose between a lean Gentoo installation CD, a live CD, DVD, live GUI, USB, or any distribution you'd like to perform the installation. You can actually install Gentoo from another Linux distribution. You don't even need a Gentoo live CD to do this. And the docs say CD, DVD here. They really should say USB. So you'll basically download an image, boot from the USB. Unless you actually do have a CD, DVD player. You can boot off of that if you want. Step 2 is follow the instructions. The Gentoo handbook provides detailed documentation that guides you through the installation process. Yeah. There's no installation program. You are the installer. That way you can apply all the customizations you desire. So before we dive in here, why would somebody ever want to put up with this? There are two things that I'll call out here. One is Gentoo is what's called a source distribution, which means that everything you install on Gentoo is compiled from source. So when you apt, upgrade, apt, install something on Ubuntu or Debian, or any of those systems, you're actually downloading pre-compiled software. You're downloading binaries. Those binaries were compiled with settings that allow it to work on almost any system out there. At scale, that could introduce some bloat. Um, if you do everything from source, you do achieve some performance increases. It's not that material these days with the modern hardware, but it's something that some people care about. And there are actually a decent number of high performance systems out there that actually use Gentoo for trying to get the utmost performance out of their systems. The other thing it does is it adds a little additional security. Okay, so when common software packages out there, say Chrome or any application you might be running that connects to the internet has an exploit out there for it. Usually, the exploits that are created for that prepackaged software, right? So when you compile your software from source, the signature in memory is going to be slightly different. So these are not like end all be all definitive statements, but those are some of the reasons why somebody might want to install Gentoo. The biggest reason I think people would want to install Gentoo is just due to the customization, right? Um, if you don't want software on your system, you don't have to have it. If, say you're in a situation where AI is hacking Linux kernels left and right, you might want to be able to quickly choose a different kernel, reconfigure kernel quickly, and then like quickly recompile all your applications that are linked to that kernel, and now you're good. You're patched. You're ready to go. There's really what this creates is an environment where you have ultimate power and control, and every single potential knob for tuning is available to you. That's really why a lot of people use Gentoo. So what we've done ahead of time to prepare for this installation is we have Gentoo running on another machine here in my office. This machine is running virtual machines, right? The other day I showed you guys Arch, Fedora, Linux Mint, Pop! OS, and Ubuntu. We're going to create a virtual machine for installing Gentoo. So first things first, I have to get the image that I want to install Gentoo from. AMD 64, so I'm going to go to downloads. By default, almost all of you guys are going to be running the AMD 64 architecture. The AMD 64 architecture is 99.9% of consumer computer hardware out there. This is just 64-bit PCs, right? I think even MacBooks are running on this architecture now. Um, Alpha, you don't have, you really shouldn't have to worry about any of these. If you know what these are, you know what you're doing, right? ARM and ARM 64, that's like your mobile devices. RISC-V is like a new one. x86 is like older CPUs that don't support 64-bit processing. Okay, so we're gonna go with AMD 64 here, and it tells you what the processor compatibility is. It's called AMD 64 because it was introduced by AMD in 2003, and then it was enabled on Intel stuff as well. So we're going to get this minimal installation CD here. I'm going to download that. That's about a gig, and yeah, off to the races. I'm glad you guys like the beard. I'm glad my fiance is not the only one. I'm a little self-conscious about it. I'll be blatantly honest. Double D says, why Gentoo versus Ubuntu? I'll be fully transparent with you guys. I run Ubuntu on my laptop, right? As you'll see throughout this installation, you don't get something usable out the gate, right? You're gonna have to like put some work in to get it to a usable state. And if you're on the go and constantly having to like reconfigure things like Wi-Fi and sound and stuff like that, you can do that. It'll just, you got to spend a lot of time setting it up. So, for a laptop that's on the go and I don't want to like worry about setting things up, um, I use Ubuntu. Now, I also like, recognize the security posture is different, my capabilities are a little bit different, all that jazz. But on my workstation at home, my servers, everything that's effectively static, network-wise, setup-wise, I run Gentoo because I can set it up exactly the way I want it and never really have to touch it ever again. I just keep it up to date. All right, so the install CD is downloaded. What I'm going to do now is I'm going to copy. What was this? Is it Gentoo? No, what was it? AMD. It's in downloads, right? CD downloads. There we go. Install. Okay, so I'm going to SCP install over to my server where we'll pick it up over there. So that's going to be machine 2. And I'll drop it in the home directory. Boom. So we'll copy that gig over. That shouldn't take too long on my gigabit Ethernet connection here. Actually, I think it's only 100 megs. Oh, it's got to be more than that. All right, done. Cool. So I'm going to SSH to machine 2 and copy the install medium to mount server VM. No. It's mount VMs ISOs. Boom. So that's in there. I don't need this anymore. We're going to get out of here. I'm going to hang on to this handbook over here and I'll show you guys how we configure a new virtual machine. So we're going to create new. Now I'm using virtualization on Linux. My setup here is libvirt, libvirt, with QEMU for emulation. And this whole user interface here is called virt-manager or virtualization manager. It's actually created by Red Hat. So we like it. It works. But what you might want to be aware of is like the machine that I'm actually running this virtualization manager on is a separate machine from the one that's actually running the virtual machines. If that makes sense. Maybe that's important. Maybe it's not. Cool. So we're gonna go in here. We're creating a new virtual machine. Choose the installation media. So I have oh, I gotta refresh this. Boom, there it is. Install AMD 64 minimal. Doesn't say Gentoo anywhere in the name. So that doesn't help. We're gonna call this Gentoo. Gentoo Linux. Sure. Setting this is required, and it just like provides some basic defaults for the profile out the gate, but we're gonna change them later. Moving forward, I actually want to give this machine like a decent amount of resources since we are compiling everything from source. It's going to take some time if it doesn't have a decent number of CPU threads or efficient RAM. So what I'm going to do here is I'm going to connect to my virtual machine engine again. I think it's proc info. Maybe proc CPU info. Yeah, I can do that. So it's just dumping all my processor details here. So as you can see, we got an Intel Xeon. It's got 12 threads. So it starts counting at 0, shows us we have 12 threads. So I'm going to give this thing, I mean, what do modern CPUs have today? They have like at least 6 threads. I'm going to give this thing 8 threads. Screw it. I'll just give it 10. Why not? And I have a crap ton of memory on this thing. So we're looking at a total of 188 gigs of memory available on this machine. So let's give it, what does it, modern machine have, like 16 to 32 gigs of RAM? Let's do 32 just for kicks. So except we need that in megabytes. Calculator. So I'm just going to fire up a calculator here. And we're going to close this window. No, that's not what I want. Close this window. Let's do 1024 is 1 gig. Let's multiply that by 16. No, let's do 32. Let's do 32. We'll multiply it by 32. That'll give us that much megabits in RAM. So we're going to drop that in there. Thank you, calculator. Appreciate that. And we'll go forward. Cool. So we're going to create a hard drive, a virtual hard drive for this thing to be installed on here. So we'll call this Gentoo 2026. Sure. And we'll give this thing 20 gigs is plenty. Plenty of storage, right? Most machines these days come with way more than that. Just for kicks, so we have a little more fun while migrating and building out the partition table. We're going to give it 100 gigs just to see how it goes. So we'll finish that. So it's creating the virtual disk that we'll use to install this thing, and boom, and then we'll use this volume as the storage, and then we'll move forward and call this Gentoo Linux 2026. And we're going to customize the configuration before we kick off the install here. So basically we want to double check a few things in the virtualization environment, the virtualized hardware, if you will, before we boot. The big thing I always change here is most modern systems use a UEFI type of BIOS. They don't use legacy BIOS anymore. So I'm going to select this UEFI BIOS. The other thing I like to double check, oh yeah, we'll apply those changes, is whether or not this guest agent is installed. This allows us to basically share the clipboard between the virtual machine and the host machine, or the machine that I'm on here. The other thing we can do is just make sure we have all the hardware that we want. Really, all you need is, some compute, you need some RAM, you need a disk, right? This CD-ROM is actually going to be removed after we're done installing. That's the boot image that we're going to install from. You need a network interface card. You can set up your network interface card on any virtual network you'd like, but that is way too much information. Sound, standard sound card. We might not, care about that much. Video is going to be virt-io. That's fine. So everything's good to go. So all I need to do here is click begin installation, and it'll start firing it up. Boom. All right. So we're going to close that. That easy, guys. We are already booted into the bootloader here on Gentoo. So this is actually pretty. I haven't seen this. This is new. All right. So I'm going to select boot live CD. And it boots up. It's going to ask you for your keyboard layout. I'm just going to go with default. Starting all the services. One of the biggest differences between Gentoo and most other Linux distributions is its init system or initialization system. It uses something called OpenRC, which is vastly different than what most systems use. Most systems use what's called systemd. I like it. I prefer it to systemd personally. It's also, you know, what I'm used to. So we're here. We're in the Linux system. So the very first thing I always check is make sure we have internet. And just ping google.com. You can see this system is connected to the internet. Great. Awesome. So uh, going back to our guide here, you can see we've effectively completed step one. We have booted a live environment. Step two is follow the installation instructions. And I'm going to try really hard to follow this to the T and bring you guys along. I have some habits that tend to creep in from time to time, but we'll give it our shot. So Gentoo handbook, we want the AMD 64 handbook. It's really not that long. It might seem long, but it's really not. It's pretty simple. If you watch me install Arch Linux, it's effectively the exact same process, albeit a little slower because we're going to compile some code from source and a few additional steps because it's got more configuration options, right? So basically, we learned about the Gentoo Linux installation. We chose the right installation medium. We configured the network, right? And so at the bottom of configuring the network, you just need to make sure you can, you know, access the internet. So I'm going to see if this works. What happens when we copy here and paste? Oh, come on. Actually, I don't need that window anymore. Can I paste in here? No, I can't paste in there. I got a mouse, but no clipboard in terminal. This is pure terminal over here. So, all right, with that, we know that our internet is working, so we skip this entire step, right? Once connectivity has been verified, here, let's just ping c3 gentoo.org, right? Ping, oops, ping count 3 gentoo.org. 1, 2, 3. It works. Cool. So I will move to the next step, which is preparing the disks. So we have a brand new disk that we configured in the virtualization manager. That disk is bare bones. There's nothing on it. It is just like a raw file on the system that is supposed to represent a disk, right? So disks are also called block devices, and you can find them in files. Everything in Linux is a file, right? So like even devices are files in Linux. There's just different types of files. Some files you interact with a little differently, but IDE, SATA, SAS, SCSI, or USB flash drives will always show up as dev SD devices. NVMe Express, NVM Express devices will show up as dev NVMe. If you use MMC, eMMC, they'll show up as MMC devices. And then virtual IO, which we are using, will show up as dev VDA devices. Okay. We need to partition these drives. We need to partition our block device here. There's a lot of education packed into this handbook. I highly recommend, like, the first time you go through this, like, read everything. You're going to learn so much about your computer. You're going to learn so much about computing in general. And there's also probably, you'll probably save yourself some gotchas if you're doing this for the very first time and you don't have clarity on everything you're working through here. But there's also, you know, some computing history in here too, right? Some people use master boot records and legacy BIOS systems. It all depends on the computer you're installing on. Some people use GUID partition tables or GPT and UEFI BIOS systems. So GPT is what we're going to use today since we elected for a UEFI system. They take advantage of checksum and redundancy, and UEFI is just overall a much better experience. BIOS is great, but we've improved since the invention of BIOS. Handbook authors suggest using GPT whenever possible for Gentoo installations. Once you create the partitions, you'll want to put file systems on those partitions. So they're calling that out, and there is a default partition scheme that this handbook will reference throughout. So we're going to follow along. We're going to do the exact same thing that Gentoo is doing. I'm going to make some changes along the way, like I don't really want XFS. We're going to use something else. But generally speaking, we need to make these partitions. The handbook tells you how to design a partition scheme. What is swap space? Swap space is storage that your operating system can use as memory if it runs out of memory. It's also where your operating system will suspend state to if your computer goes into a suspend mode, and stuff like that. So, when installing Gentoo on a system that uses UEFI instead of BIOS, it is essential that an EFI system partition is created. The instructions below contain the necessary pointers to correctly handle this operation. Yada, yada, yada. And then they give you an example command here on how to create the file system for EFI. Now, one thing that is important to understand is EFI is basically standardized around the FAT file system, which is a probably not the best file system out there, but it's what Windows has kind of shoved down everybody's throats. So we are going to dive into partitioning the disk with GPT for UEFI. Super cool, right? So we want to see the current partition layout on our system. The command to do that is fdisk. So I'm just going to, no, don't want that. Oh man, I killed the wrong window. Oh man, we're freaking, now I'm doing it again. There we go, there we go. All right, here we go. So fdisk dev, again, VDA, because we're on a virtual file system, and when I hit print, it just tells us information about the disk. There are clearly no partitions on this disk. We just created it, right? So with that, let me fire up the browser again because I killed it. Maybe. No. No. Oh my gosh. Freaking amateur hour over here. Still getting used to this new. There we go. Alright. Still getting used to this new window manager, guys. Bear with me one moment. So, if you ever lose your spot, boom, get started. Handbook. AMD 64. And we are at preparing the disks. And we are partitioning the disk with GPT. Okay. So we're in fdisk here. What we need to do is just hit G and enter, and we created a new disk label. You guys see that? Let's do this. See that? Create a new GPT disk label. What is going on here? There we go. All right. Next thing we need to do is we don't have any existing partitions to remove, but we need to create the primary partitions on this disk. So you will hit P for primary. Oh no, P is print. New to create a partition number. That partition number will be 1. First sector is the very first sector on the disk where we can start building a file system or a partition. So we're going to hit enter for default. And then over here, oh, 1 gig. There it is. Sorry. We want to make this partition, the EFI system partition, 1 gig. Boom. Done. Now when I hit print, you will see we have one partition, dev VDA1, with 1 gig in size. Type is a Linux file system. We need to change this type to a different type. We need to change it to EFI system. So you can hit L to see all the types, and I think EFI is type 1. Yep, so 1. Client, change type of partition Linux file system to EFI. Boom, you see now it says EFI. And now we need to create the swap partition. So we're going to hit N for a new partition number. Partition number is 2. First sector is going to be right on top of the last partition. And we will make this one 4 gigs in size. Boom. That's Linux file system. Now we need to change the type of this file system to Linux swap. So we'll hit T for type, 2 for partition 2. I could hit L to show all of them, but my docs over here says 19 is swap. Boom. Change type of partition Linux file system to Linux swap. So now when we print, boom, we got 2 partitions there. We're going to create the last one here, which will be our root or system partition. We will stack it on top of the swap partition, and we will consume the rest of the disk. And now you see we have 3 partitions. We don't need to change the type of the last one. It defaults to Linux file system. Cool. So we're going to scroll through here. Oh, look, we can change it to Linux root. Let's try that. Let's try it. Type 3. What is it? 23? Oops. 23. Now, Linux root, x86 64. Cool. All right, we're done creating our partitions. Now we just need to write them to the disk. So we hit W to write, and it syncs and it quits. That's simple. Cool. All right, so we're going to skip this section here, partitioning the disk for BIOS, because that doesn't apply to us, because we're using UEFI. Now we're going to create the file systems. This is telling you about the various different types of file systems. I'm going to use FAT for the boot partition or the EFI system partition. We're going to use BTRFS for our root system, and these are the commands created to do that. So instead of makefs xfs, I'm going to do makefs.btrfs. I'm not going to pass it any options. I'm just going to say dev VDA3, because VDA3 is our root system here. So boom, done. File system created. Moving right along, we will build the FAT partition of format 32 on the EFI system. Boom, done, and we will churn dev VDA2 into a swap file system. Cool. All done. Now we can actually activate swap. Now I think the command swap on, yeah, swap on dev VDA2, and now the system can actually use that part of the disk as swap. And so if I do free-h, you can see we got 4 gigs of swap here, right here. Boom, boom. Pretty simple. Okay, swap on. Cool. Now we want to mount this partition so we can start installing Gentoo on it. Right? Pretty simple stuff. Double D says fat file system, PHAT. Pretty hot and tempting file system. let's see here. And he got his quiet on swap space. Ha! I like the jokes. I like the jokes. Okay, so we're going to be working in this these mount directories here. Looks like the Gentoo directory has already been created for us, as you can see. So what we're going to do is actually going to, we don't have to make the directory, it already exists. So we're going to mount dev vda3 to mount Gentoo. And if you're wondering how I'm typing so fast, I hit tab and it auto completes where available. So boom, mounted. Now when I type mount, I can look for Gentoo, and I can see dev vda3 is mounted on Gentoo. Cool, rock and roll. All right. The guide here says make directory parents Gentoo EFI. I like boot instead of EFI. This is just my personal preference. So I'm going to use the boot directory instead. So what I'm going to do, I'm going to make directory parents mount Gentoo boot. We're going to use the boot directory instead of EFI. And we don't have a separate temp partition. Do we want to mount? I think we want to mount. Oh, it's just mounting the root partition. Okay. Well, I guess we'll mount boot later. I would normally mount boot right now. That's what I would do. But maybe we're not doing that right now. I'm gonna do it. Why not? Mount Gentoo boot. Boom. Okay. I don't, doc's going one way. I'm gonna go in another way. We'll see what happens. All right. So now we need to install the Gentoo installation files, right? This is pretty easy actually. Basically what we're going to do is we're going to download a base Gentoo system with some basic utilities and configuration files. Pretty much the system we need to start building the rest of the Gentoo system. So they call them the base installation files or the stage files, right? So gives us some tips on choosing a stage file. These are important. They have to match your system and your desired outcome here. They should match your preferred init system or your initialization system. Gentoo does support systemd. OpenRC is probably the one that most people on Gentoo use if they've been using it for some time. There's also the option to choose multiple library support, right? If you want to support software that doesn't work on a 64-bit system, you might want the multi-lib. These are edge cases, guys. Big edge cases here. You shouldn't have to worry about this on modern hardware, modern software. It's really only for people who are using some pretty esoteric software at this point. We're going to go with no multi-lib, pure 64-bit, and we're going to get started over here. So before we download, we'll want to make sure everything is set up properly to handle these files. So we're going to cd to mount Gentoo. We're going to check our date, Friday, May 1st, UTC. That looks good enough to me. We don't need the network time protocol. We're not going to manually set our date. We are not going to try to browse to the web through this terminal here. But once we find our stage file that we want, we're going to use wget to download it into here. So we're going to go to the download section of Gentoo here. We're going to go to AMD64. Here, this is where we got our installation CD. We're going to go to stages. Okay. And you're going to see there's default stage archives, no multi-lib stage archives, and hardened stage archives. Gentoo is notorious for being super secure, and on top of their default security, they even have an extra additionally hardened environment for some people. This basically helps prevent you from installing potentially risky software. So we're going to go with a default desktop profile OpenRC. Actually, I'm not even going to go with that. We're going to go super basic. Right at the top, OpenRC stage build here. You'll see the URL down below links to an archive. So what I need to do is actually copy this link into there somehow. But instead of doing that, we're going to try something else. We're going to go Gentoo org downloads AMD64 stages. So let me try this. I guess we're using the terminal browser. Links. Yeah. Gentoo.org downloads. Okay. Alright, so we're in downloads. Where are we going here? We're going to downloads, AMD64, boot media. We're going to go to stages, and we're going to go to OpenRC default stage archives. We're going to hit this, and we're going to save this file just like that. And now it's downloading, I think. I haven't used links in forever. What does this do? Downloads? No downloads? Wow, that was quick. It says it's about 283 megs. Man, that was super fast. What's in here? It's in there. SH 271 megs. I guess it downloaded. All right, cool. We got it. Nice. All right, so back in the docs, we don't need to widget that. I wasn't typing that whole URL there. We used links to browse here and download that. We can verify, get the GPG key and like verify the checksum of all that. But we're gonna skip that step. I just trust that download. That was so freaking fast. All right, so now we need to. Yeah, we're not verifying and validating. We are installing the stage file here, okay? So basically what we're going to do is just extract that stage file, okay? So that's going to be a tar command right over here. We're going to type tar x pvf stage, and we're going to exclude attributes or include extra attributes. This is single quote, all single quote, and numeric owner. Every file in Linux has an owner. We want the numeric owner, not the owner names, just in case the system's different. So here we go. Boom. And then it's extracting all those stage files. Now it should be extracting it in Mount Gentoo, which is going to be our root file system on our disk. So now we wait. Done. That was easy. Alright, so I'm in Mount Gentoo already, so if I do this ls-l, boom, you'll see we got our basic Linux system in here with boot, dev, etc, home, some lib directories, yada yada yada, user var, etc. Pretty cool, right? Now we're going to start setting this system up, and here's where we dive into one of the biggest ways you will configure and customize your Gentoo system. So on Gentoo, the package manager is called Portage. Portage, again, downloads source code and compiles it for you. And you want to be able to customize that, right? So what you want to do is edit, what is this? Etc or mount Gentoo etc portage make.configure. If you've ever run a QI node, you know what the make command does. Here is where we're going to set some common flags where we can specify specifically what CPU we have, all that other jazz. Over here it tells you exactly what these flags actually do and how to actually tune your source code for your native system. Okay. The makers have made this even easier in the past. Like I used to actually set like my CPU model in here, but these days you can just do architecture native. So mark, we're going to do mark equals native and leave it at that. We will control X to save and exit. Boom, done. There's also Rust flags for this. This is like so much has changed. So much has changed since the early days. There used to never be Rust flags, but now there are. So you can set some Rust flags if you want, if you're using Rust programs. Let's actually try this. Rust C target CPU help. No, there is no Rust C command. Well, we can set that later if we really care. Make ops is another variable we can set. So basically, make ops is a way of tuning the compiler to take full advantage of your system. So if we go back in, we can set make ops in here to, let's do make ops let's see, we have, what do we have? 8, 10? We got 10 CPUs on this system. So what the docs recommend here is set makeops jobs value to the same number of threads returned by nproc. Set makeops load average slightly above the number of threads returned by nproc due to it being a dampened value. So for example, instead of 4, we're going to use 10, and instead of 5, we're going to use 11. That's simple. All right, moving right along, we're gonna start installing. So, what we need to do is prepare to change root of our environment here into the actual Gentoo system, so we can continue along. And checking in on some things over here. Yeah, so we have some networking information we need to copy over, so we're gonna copy dereference the current Etsy resolve DNS resolvers to mount Gentoo Etsy. Boom. So now we can resolve DNS in our new environment. And we're going to copy over everything this Gentoo live CD knows about our hardware. Again, everything in Linux is a file. So we're going to copy all our hardware references over into the new system. We're going to copy the proc file system. I say copy. Basically, we're remounting the proc file system from the current proc file system into mount Gentoo proc. We're going to rbind sys into mount Gentoo sys. We're going to make that a slave. Mount Gentoo sys. And we're going to do the same thing for dev. And we're going to make that a slave. Make our slave mount Gentoo dev. And we're going to bind run to mount Gentoo run. And we're doing this because we're effectively changing our root directory for this environment that we're currently in. So then everything we do from that point out is inside our actual installation. So we gotta bind that, and then we gotta mount make slave mount Gentoo run. All right. Clearly, Gentoo is not woke. I kid. It's not Gentoo. It's somebody else. But let's see here. When using non-Gentoo installation media, this might not be sufficient. So basically, The file systems need to be made available, yada, 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 yada. Yeah, so don't care about that. Now we're going to go ahead and change our root, right? And what we'll do is we'll also change our prompt so that we know exactly where we're at here, right? So where was I just typing? All right, chroot mount gentoo bin bash. So now we changed our root into mount gentoo and opened a shell, opened a bash shell. Now we're going to update our terminal's profile here. And we're also going to update the prompt so we know exactly what we're looking at. So this is in chroot and ps1. I think that's it. Boom. Yeah. So now our prompt's updated and it says chroot because we're chrooted into this file system. Moving right along here, yeah, it says mount the bootloader. It's already mounted, I believe. Grep boot. Yep, it's already mounted. Already did that. Beat you to it. Yeah. So that's that. I'm kind of breaking standard here by using the boot folder instead of the EFI folder. I'll just let you guys know that. But I'm not the only one who does this, so don't beat me up too bad. So now what we need to do is start installing some packages. We're in our Gentoo installation. We have the base system set up and installed, and we need to start, building out the rest of the basic packages that we need to get this thing up and running. So Gentoo uses a package manager called Portage, and we need to update our current list of packages. So there's a way to do this. For those who are behind restrictive firewalls, you can emerge WebRSync. We're just gonna rsync. So I'm gonna do emerge sync and just let it go. And what it's doing is it's receiving an incremental file list of all the latest packages. And yeah, it's updating. If you're familiar with Ubuntu apt and you've ever done like an apt update, this is effectively what you're doing. You're doing an apt update, except on Gentoo's portage system. It's emerge sync. You're syncing emerge or syncing portage, more like it. So while that churns, what should we do here? What should we do? There's going to be some moments of like waiting from here on out when we start installing things. It takes a little while. It's not as quick as a binary file system. Again, we're going to be compiling software from source. And certain packages, like I think I could show you guys. I am compiling Chromium from source on this screen right here. This is what it looks like. If you look in the top right corner, we are at step 28,000 of 55.3 thousand steps for Chromium, right? Chromium, massive browser, huge package. Even on my dedicated hardware, it takes a while. It takes a while to compile. So installing programs on Gentoo is not quick. Now, are there binaries that you can install in Gentoo? Does Portage support binaries? Yes, it absolutely does. So if there's one or two packages that you just never want to wait for, you can install the binaries for those packages instead of the source code. I am electing not to do that because that's my choice. And if you want to wait, 6-8 hours for Chromium to upgrade, you can do that on Gentoo. Some see that as a plus, some see it as a negative. At the end of the day, it's all about choice, guys. It's all about choice. So, real quick, while this screen just hums, I'm going to take an audio pause and go hit the restroom real quick. Be right back. All right, we are back just in time too. Looks like the sync is wrapping up here. It is verifying the cache. Well, not the cache, but it's verifying the repo that it just downloaded. And boom, we're in. Every time you update in Gentoo, if there is relevant news, if the developers are trying to inform you about a change in terms of like architecture or package dependency conflicts, anything like that, they always make it available to you with these little notices like this. So if you are running Gentoo and you use it regularly, it is very, very important that you read this news. So what we're going to do is we're going to select news read. And we get all this news. I can't even scroll up. Dang. So I missed it. I missed all the news. But that's okay because we have a bare bones system. The Gentoo devs are going to take care of us and make sure that new installs don't break anything. Rsync mirrors, we can speed up downloading the available package list using emerge sync by selecting a mirror that is geographically. Yep. Okay. Optional updating the Gentoo ebuild repository. Part of me thinks we need to do this again. I always did this. Why did I always do this? Gentoo also has many rsync mirrors. Yeah, so we're already using rsync. So, okay, well, I don't think I have to do that. Anyways, we did that. We did emerge sync instead of WebRSync. Tells you about reading the news. Let's try select news list. And we can see the news items. So migration required for OpenSSH with LDAP, change of accept license defaults. There's an upgrade to PAM, new OpenRC display manager initialization scripts, right? So this is 2021. These items go all the way back to 2018. This is crazy. This is crazy. These are the latest news, right? So what most people expect in a Linux distribution or just any operating system is major releases. Gentoo doesn't do major releases. They make architectural changes and then they inform you about them through the news. And then if you have a hyper customized system, you need to plan for those changes to impact your system in the future, right? So I will never have to like reinstall Gentoo on this system ever again. I will just have to maintain it through portage, read the news when it impacts me, take action when it doesn't. I'm good to go. I'm solid. So that's another reason people might want to use Gentoo. Okay, so what packages are we going to install? What configuration defaults are we going to get for these packages? All that jazz is baked into profiles, what Gentoo calls profiles. So if you want to see the profiles, you can select profile list, and you can see all the profiles. There's a lot. I'm going to pipe this into less so we can actually page through it. And you see at the very, very top, the first profile, is the one we selected when we downloaded our stage 3 tarball, right? Um, Default Linux AMD 64 23. The profiles have version numbers. Stable. Okay, easy enough. I could have went with a systemd profile. Notice it's not default. I could have gone with a desktop profile. I could have gone with a desktop systemd profile. I could have gone with a desktop GNOME profile, desktop GNOME systemd, desktop Plasma, which is like KDE or Qt. No multi-lib, LLVM, hardened. Here's that hardened profile I was telling you about earlier, right? All these things are basically setting initial package lists and um, configurations for these packages. You can choose a standard profile and customize packages to your heart's desire. You can start with one of these profiles and, through customizing your system with, the make configuration file and portage configurations, you can end up not looking anything like any of these other profiles or looking completely like a profile that you didn't select. So this is basically just like a starting point, right? Like by default, what customization options and packages do you want to be able what packages do you want to install and what do you want those default configurations to be like, right? So we're starting with the very basic one, right? Super simple. We don't need to change it. If we wanted to change it, let's see here. We could select profile set and we could pick a number here. So I could set it to 2. And then when I go to profile list, I can see now 2 is selected. Systemd, right? I don't want systemd though. I don't really like systemd. So we're going to set it back to 1. Boom. Done. Cool. Moving right along. Here you see how to set your profile. No multilib, yada, yada, yada. We can add a binary package host if we don't want to compile from source. We're not going to do that today, so we're going to skip that process. We could set features to get binary packages when they're available. We're going to skip this step because I want to give you guys, the real Gentoo experience, right? Optional, we could configure use variables. So use variables are that next layer of configuration in Gentoo. Let's bust this out for a second here so you guys can see. Oh, come on, cat. What use actually does for you. Where did use go? So use is a way of configuring packages to compile with special features or to disable special features that you don't want in a package. For example, I use Pipewire for all my audio backend. I do not use Pulse Audio, right? Pulse Audio is another audio backend service. There's even an older one called ALSA, ALSA, right? I use Pipewire. I don't need Pulse Audio. I don't need ALSA. So when I set my use variables for packages, I make sure that Pulse Audio is not in there, that ALSA is not in there, and that Pipewire is in there, right? So just as an example, that's how you can use the use variables to configure your system. By default, you can see what the defaults are by using this little command here. Let's try that out. Oh man, I keep losing my spot whenever I change my screen size. Annoying. Here, so let's try this. Emerge, info, grep, use. What do we get? Oh, typo. Here we go. Boom. So you can see the default use variable. This comes from my profile that I set earlier, right? You also got some other features in here as well, like where's the mouse? Mouse is acting funky. Python, CPU flags, yada yada yada, kernel. There's a bunch of variables in here that you can use to configure the packages that you install. Video card support, audio support. There's even licenses, right? So you can prevent your system from installing packages that require a specific license. Um, Stuff like that. Pretty cool stuff. So we're not going to change this, but to demonstrate how this works, you could set these use variables globally or on a per package basis. I'll show you how to do that later, but globally, you could set them in here by just typing use equals, and you could say, I don't want GTK, I don't want GNOME, I'm going to use Qt and KDE packages only. I don't want GNOME, I want KDE stuff, right? So that's an example of how to set that. What I will do is let's do use equals, let's do pipewire. That's easy enough. Yeah. I can also say I don't want X. X, we'll get into window managers later, but that's another option there. I can say I don't want pulse audio, right? If I could spell. Yeah, that's an option, right? So I'll go ahead and save that just as an example. But that is now configured globally across the system every time I want to install a package. Here is where we're going to try something cool. We're going to try and configure our system even further by getting more specific with our C flags, right? Our CPU flags that we set earlier, right? So there's actually a package that can help us do this. And I'll show you what this looks like with use and all those other things involved. So I can emerge, I can ask, I say, ask me whether or not I want to install this before automatically installing it. I can also pretend, right? Or I can use the shorthand ask pretend. And then one shot means just install this package. Do not install any of the dependencies required by this package. This assumes you already have those dependencies installed. And we're going to do app portage CPU ID to CPU flags is the package here. So when I run this, Gentoo is going to search the repository and say, yep, there's one package available to install. N means it's new, which means I don't have it installed on this system. And this package does not have any use flags options, right? So I can't configure this package anymore. I can just install it. So I'm going to remove pretend, and it's going to ask me, do you want to install? And I can type yes, install, and it'll install it. It'll download. And here you see it's configuring the source code, and now it's compiling the source code, and it is done. And now it's installing the package. That was really quick, right? Not all packages are created equal. That one was a little bit of source code. Look, you got 1, 2, 3, 4, 5, 6 files here, 7 maybe, that it actually had to compile. And now it's ready to use. And I can type CPU ID, I can hit tab, and it'll tell me all the CPU flags I have available to me, right? And I can copy that output into package.use 00 C flags, right? So one way we can configure per package use flags is by using the configuration directory etc portage package.use. If I look in here, there's nothing in here, right? But what I can do is I can create this file that'll be used for all packages. All. And then I'll take the output of CPU ID to CPU flags, and I will pipe it into 00 CPU flags. Boom. Now, when I ls, there's a CPU flags file, and if I cat that, you can see we have all the CPU flags in there. Pretty cool, right? Cool. Video cards, don't really care about this right now, but what we can do, I wonder if lspci is installed. No. lsusb, no, that's not installed. You know what? Let's go ahead and install those utilities because we need them, right? PV, PC, I think it's called PCI utils. Oh, without the dash. Okay, let's try that. Boom. All right, so here we go. You see the PCI utils is a package we can install. It's going to pull in these dependencies, hardware data, libudev. So it's going to compile these dependencies and install them before it compiles and installs PCI utils. You notice there's some other use flags I could add to continue to customize PCI utils. I can also take away some use flags if I want to using a custom package.use file, right? And so what I like to do is I like to create package.use files named after the packages they're supposed to configure, and we just need to echo the configuration. The configuration usually looks like the reference to the package. So this is sysapps PCI utils, and then I'm going to add the use flags that I want. Just for kicks, let's add DNS. Not really sure what that does with PCI utils, but we're going to do that, and we're going to pipe it into the PCI utils file here. Now when I do an ls, I got a PCI utils file. If I cat PCI utils, that's what it looks like. And now when I try to emerge again, we should see the DNS use flag enabled here. Pretty cool, right? Didn't bring any additional dependencies, just kind of like activated some features with PCI utils, it looks like. So I'm going to go ahead and install that. So it's going to do some pre-merge checks. It's going to get hardware data. It's going to configure and compile and install. Done. Moving on to the next one. Download, configure, compile, install. Now it's moving on to libudev. Oh wait, yeah, it's installing libudev. Now it's installing PCI utils. Download, unpacking, compiling. This is a much bigger package. So compiled, installed. Boom. Cool. Now when I do ls PCI, we can see we have some PCI hardware in here. And yeah, we got a bunch of QEMU bridges. We got a VGA compatible controller called virt-io 1.0 GPU. We got a host bridge. We have an audio device. We have an ISA bridge, a SATA controller, Ethernet controller. All these virt-io devices are indicators that we are on a virtual machine, right? So we did that because we like using these utilities later to find out what our hardware actually is. I'm going to try another one. I think it's USB utils. One of these has a hyphen in it. Nope, they took the hyphens out. Okay, so this one installs libusb and USB utils. So these are just like little utility programs that I like to use to inspect my hardware. So we're going to go ahead and install these. Meanwhile, we're going to look through. We set our CPU flags. So we're going to look at our video cards here. This is important because we are on a virtualized machine here. You can see we're looking at QEMU KVM, and the video card is VIR-GL or virtual GL. Okay, so we want to set video cards so our packages install with proper support for our graphics card, our virtual graphics card here, VIRGL. So we'll get back to that in a second once USB utils is done installing, which it is. Cool. Now with USB utils, I can do LSUSB and see my USB devices, right? Which, you know, we're not really using right now, but maybe we'll in the future. So like having that utility. Cool. So what we want here is we're going to edit. Notice I'm in the Etsy portage package.use directory. I'm going to create 00 video cards file. Ooh, too many zeros. Video cards file. We're going to do all/all video cards, and we're going to do -all to eliminate all the other video card drivers, and we're going to add Virgil. Yeah. Cool. Cool. Boom. Easy enough. Okie dokie. What's next? What is next? Let's see here. Yeah, so we did the video cards. Here's an example. Yada, yada, yada. Accepting licenses. So starting with, profile 23, they created a mechanism that was allowed system administrators the ability to regulate the software they install with regards to licenses, right? If you want a system free of any software that is not open source approved, others are simply curious of what licenses they're implicitly accepting. So this is a pretty cool feature. Every once in a while, you might run into a package that is not open source and requires a separate license for you to accept. Portage handles that via accept license variable, right? Pretty easy. By default, we accept pretty much all the OSI approved free software licenses, GPL compatible licenses. We're going to view the licenses that we currently accept by showing env-var accept license. So with that, we'll go over here. And we'll type portage query env-var accept license. Free. So we accept all free licenses. Okay. So we might want to accept some additional licenses out the gate. These are pretty easy, excuse me, to add. I like adding these in make.conf. etc portage package make.conf. And you can just add those down here by saying accept license equals, and instead of putting this negative all value in here, we're going to add to our list of licenses, and we're going to say at GPL, if I could type compatible. We're also going to add at FSF, Free Software Foundation approved. We're also going to add OSI approved, and we'll also add free software. And some of these are probably redundant. Like if you read, where was I? If you read this, basically some of these include the others, yada yada, but it's just kind of handy to call them out explicitly. So we will cap this, save it, and move on to the next task. The next task, optional, updating the world set. This is a list of targeted packages that you want to keep up to date. Every time you install a package manually, like I've been doing, it's added to the world set. So when you update your system, you update all the packages that you asked Gentoo to install. We don't need to do that right now because we're going to be doing it along the way. We do need to update our time zone. So one way we can do that is looking at the time zones that are available. And those are in ls -l user share zone info. You might be familiar with this from the Arch Linux install. There's a lot of time zones in here, right? So I like selecting America, and then I usually use, let's do this. Let's pipe this to less so we can page through it. I think it's Chicago. It's basically the same time zone that I'm in right now. You can also try US, and you can see they have Central in here. So let's go with US Central. And then basically all we got to do is link to it by creating a soft link here. Do this from root, I guess. ln-sf user share zone info US Central at etc local time. Yeah. All right. Boom. There we go. Easy enough. Yeah, I was wondering why we had this dot in front of here, but here's the note. It tells you, educates you along the way. Cool. Locales. The default of Gentoo Linux locales is like the languages, right? The languages used on your system. Locales specify not only the languages that the user should use to interact with the system, but also the rules for sorting strings, displaying dates, times, etc. Locales are case sensitive and must be represented exactly as described. A full listing of available locales can be seen there. I just, we go with the US language here. So we're going to nano etc locale.gen, and we got all of these languages in here. We just need to find ours and comment it out. So I'm going to do enus.utf8. So here's enus. I want the we're gonna add a custom entry. We're just gonna append to the top and follow the guide here. So enus.utf-8 space utf-8. Does that look right? Yes. 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 That looks right. Cool. Save that file, and then we gotta generate our locales. So we just do locale gen. There we go. Done. We can also select our locales with eSelect locale list, and you see by default we're using the standard UTF-8 locale. So I'll just leave it there for now. That's fine. Looks like the handbook sets 2, so cool. We can also manually set system locale settings, but this effectively changes our profile in the environment we're currently running in. So in order to refresh, we're going to env update and source etc profile and reset our terminal here to ps1 equals chroot ps1. Boom. Done. Cool. Now we're moving on to configuring the kernel. This could be the longest step in the process if you want it to be. This is where a lot of people get hung up. A lot of people get hung up on configuring their own kernel. The kernel is the first piece of software, the root software that is running your entire system. It is the software that helps your applications communicate with your hardware. It manages all the hardware for you, provides that hardware to what we call user land for you to interact with it. It's essentially what Linux is. Linux is just a kernel. All right. Distributions are packages of Linux with all the userland applications and helpers on top of it, so you can actually use your system out of the box. Gentoo gives you the option to configure your own kernel. Um, we are going to skip manually configuring the kernel. However, I highly recommend those who are interested and want to learn a lot, probably too much, about Linux and about their hardware, read through these docs, right? It walks you through basically manually configuring your own kernel down here in alternative manual configuration, where you can download the source code to the kernel, configure it, compile it, and install it yourself by hand. Configuring by hand, you're going to walk through all this menu on what drivers you want to support, which ones you don't want to support, what kernel configurations, all that jazz. So it shows you all the options and what you should be looking for. It is not as educational as it could be, but it gives you a really good starting point if that's something you're interested in. We are definitely not going to do that today. We're going to use a pre-configured kernel that works on almost all hardware. So starting at the top here, we definitely need some firmware, right? A lot of hardware these days depends on firmware that basically gets loaded into the hardware at runtime. So to begin, we're going to install the Linux firmware here. So move this to the side and simply emerge ask, right? I like to do pretend verbose sys kernel Linux firmware. Most of the time you don't have to type this whole line out, right? It just helps Gentoo find it faster, but Linux firmware, there's only one package named Linux firmware, so we can do that. And it looks like this does not want to install, right? And the reason it doesn't want to install, it'll tell you right here, basically it is masked, which means that it's blocked by a license. And that license is the Linux firmware redistributable license, right? So what I can do is I can go, I can do, let's do that. We can do this per package as well. So I can, I gotta check my other system real quick. Hold on. I think it's, oops. Let's try this. ls, wow, caps lock is on. ls etc portage package accept, where is it, license? License, yeah. So I can go into etc portage package.license, which doesn't exist, but I can make this directory and it'll work just as expected. So I can make this directory, and then I can go in here. I can change directory in here, and then I can add syskernel Linux firmware, and it's so echo syskernel Linux firmware redistributable, and I can put it into Linux firmware. Now I can cat Linux firmware. Did I spell that right? Linux firmware redistributable. Yes. And now when I try to install it again, I shouldn't get that same warning. Nope, it's gone. All right, so basically what I'm saying is I accept this license, and these are the use flags that it'll use to compile and install this package. So defaults are good for me, so I'm just going to go ahead and fire it off. So it's going to install copy IO and alternative copy IO, configuring the source code, compiling the source code, installing the package. And obviously this one is the most intense piece of source code we've installed yet, so it's still configuring it. Take a sip of your Bang Energy Lime Pop Drop. Watch this churn. In the background, you can do fun things like read the matrix. I kid. All right. Copy IO is being installed. Now we get the alternative version. Cool. And now we're installing the firmware. Configured, compiled, extracting. This is a lot of Wi-Fi drivers, which we don't have, but other firmware might be handy. There's some Radeon firmware, some AMD GPU firmware, a lot of AMD GPU firmware, other networking firmware. Close this. Some Intel firmware, some NVIDIA firmware. I don't even know what QC is. i9-15. It's like an old Intel graphics card. More NVIDIA firmware. Some MediaTek firmware. I want to say 99.9% of this we won't be using. But for those of you out there installing Gentoo on a real system, you're definitely going to use enough of this package to want to install it. I promise you. It's definitely worth installing. I'll just say what I'm going to do eventually after this live stream is edit this video into something that's much easier to consume. So appreciate y'all tuning in right now and hanging out with me today. Again, folks, if you say hi in chat, we're hooking you up with some Kwai. All right. That's a lot of firmware. But it's done. Cool. And you notice, because we installed something that there's a news item for, we can select news read. Gentoo lets us know there's something important we should read. And again, I keep forgetting to pipe that to list. But, yep, something about Python. Using the init RAM fs. So just some notes there for those of you who are interested. You can check that out. We don't care about soft firmware. We don't care about microcode. Generation. Okay, so install kernel. Install kernel may be used to automate the kernel installation, init RAM fs generation, unified kernel image generation, and bootloader configuration, among other things. Implements two paths of achieving this: the traditional install kernel originating from Debian and systemd's kernel install. Which one to choose depends, among other things, the system's bootloader. By default, systemd's kernel install is used on systemd profiles, while the traditional install kernel is default for other profiles. So yeah, so we needed to install kernel. At this point, it's important to think about what bootloader you want for the system. We're going to go with GRUB. GRUB's great. It's what a lot of people use. There are other bootloaders, but I'll be honest, they're not really worth mentioning. But we definitely want install kernel. So over here, we're going to merge again, pv install kernel. There's some use flags that we might use later. Probably don't need them right now. I don't know. We'll find out. But we'll just go ahead and install it. Downloaded, configured, compiled, done. Easy peasy. Cool. So we're not going to use systemd boot. UEFI based computer systems technically do not need secondary bootloaders. Secondary bootloaders exist to extend the functionality of UEFI firmware during the boot process. Using a secondary bootloader is typically easier. Therefore, EFI stub booting is not guaranteed to work on every... Okay, so we don't really care about that. But let's read the news real quick. Select news read. This time I'll pipe it to less so we can see exactly what the news is trying to tell us from the top. Install kernel merge, yada yada yada. Previously sys kernel install. So user action required, grub users. Okay. So 99.9% chance this does not apply to us because we haven't even installed and configured grub yet. But it's important to note. Previous sys kernel install kernel. Gentoo provides kernel installation and automation for users of grub. The new syskernel install kernel provides the same functionality, which now works with both traditional and systemds. Users of grub should therefore check that grub use flag is enabled to ensure that systemd kernel install uses the correct layout. Users of grub may wish to explicitly choose whether traditional install kernel or systemd kernel install, in which case they may do so via use yada 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 is renamed. Therefore, no user action is required to upgrade to the new package. So, this is a grub use flag. Check to see if the grub use flag is enabled. I don't think we even had a grub use flag on this package. Oh, we did have a grub use flag on that package. Okay, so what I'm going to do is set the grub use flag on this package, and I'm going to do this in the package.use directory. I'm going to say sys. Actually, we're going to use grub globally, right? So might as well set it globally. Make.conf, and in use over here, we're going to say grub. All right. So now, when I go to reinstall install kernel, we should get the grub use flag, and it should be highlighted here. That means it's new, right? So we're going to rebuild this package since we already have it installed. There's a new use flag from the previous build, and this is actually going to pull in dependencies. Okay, so it's going to pull in grub, EFI boot manager, LVM, free type, grub themes, EFI, like all these dependencies. In order for install kernel to fully support grub, you actually need to install grub, right? So there's your dependency tree there. Good thing I read that note. We'll reinstall. We'll bring in a whole bunch of additional dependencies. So good to know. Read the news, guys. Read the news. You want to read the news on Gentoo. Definitely a necessity. So again, take a sip of your favorite drink. Check your social medias. Check your email. Let's see what's going on in the Quiet Discord. There's a very interesting conversation happening in Discord right now. How do you guys feel about wealth tax? Share your thoughts in chat. This is super curious. Super curious. Dang, the rain is really starting to come down outside. 6 of 9 packages installed. We're moving along here. Installing GRUB. Bakering GRUB. GRUB's a bit of a beast. I mean, not really. I'll be honest. It's just a bootloader. I say just. It's also highly configurable, supports crap tons of hardware. Compiling GRUB. So again, what we just installed is a utility for installing our kernel. And because we're going to choose the GRUB bootloader for booting our kernel, we needed to effectively recompile that package with support for GRUB. And we did that by enabling a use flag, just like this, which I totally skipped the first time. Looks like they use the same folder file structure that I was doing. And I probably learned it from them, I'll be honest. But yeah, we totally skipped this step. So we're kind of doing it over again, but we didn't lose out on much time because the actual install kernel package takes hardly any time to install. We're on it right now. It'll be wrapped up here shortly. Then from here, this is system dboot, EFI, stub. Excuse me. We're gonna need to create this directory if it doesn't exist. And look, we have some new news items to read. So let's do. We got 2 news items now. eSelect news read. Pipe this to less so we can actually read them. LVM default use flags. Looks like this applies to GRUB. Don't really care about this right now. And GRUB upgrades. On UEFI platform, the GRUB install allows core image to be placed in 2 different locations: EFI Gentoo, GRUB, and EFI boot, etc. On upgrades, it's common for users to mismatch GRUB install options they use for current and previous versions of GRUB. This will cause a stale core image to exist. Yada yada yada. Booting the system using this will likely fail to a simple mismatch. Okay, cool. We don't care about that yet because we've never run GRUB install on this system before. What we do need to do is see if the EFI directory exists. So remember, we didn't use /EFI, we used /boot. We're looking here, there is no EFI directory, so we need to make directory with parents EFI /Gentoo. There it is. Boom, boom. All right, so it looks like installing GRUB automatically created the GRUB folder in boot, and installing firmware automatically dropped some AMD firmware in here. So that's pretty cool. Going back here, an initial RAM-based file system may be required for a system to boot. A wide variety of cases may necessitate one, but common cases include kernels where storage file system drivers are modules, layouts with user or var on separate partitions, encrypted root file systems. So we shouldn't need any of these. But in case we do, we might want to install Drake. I knew we needed that. Gosh dang it. Okay, so let's portage package.use install kernel. Kernel install. What's in here? Nothing is in here. Oh, you know what we'll do? Let's try this. Let's nano install kernel. Let's do sys kernel / install kernel Drake. Sure. X, yes, enter. Actually, you know what I'm going to do? I'm going to show you guys how to build really cool bootloader and a whole boot up system, customize it so it looks absolutely gorgeous and unlike anything anybody's ever seen. So you know what I'm going to do? I'm going to rm install kernel, and we're going to set this globally. Say portage make.conf. We're going to add Draycut to our list of global use. All right. And now we're going to emerge again, install kernel, make sure it supports Draycut for generating init RAM file systems. This is effectively the preloader to the kernel. So first you have the UEFI basic input output system on the motherboard, which loads GRUB, the bootloader. GRUB, the bootloader, will load up the init RAM file system or the initial RAM-based file system to activate your hardware and get it ready for the kernel. And then it'll pass off to the kernel and your system will boot up. So we might use this out the gate today, we might not, but it'll be good to have it in the long term just in case we ever need it. So pretty simple stuff, really small packages, not too painful to reinstall with that. So we got that covered. Bootloaders such as systemd-boot and EFI stuff use kernel arguments of the running system. By default, because of the wide range of ways Gentoo can be installed, users will randomly get tripped up by this. To help solve any issues this may cause, syskernel install kernel will check if it's running in a chroot and fail if the kernel command line is not explicitly configured. Otherwise, the bootloader will use the install media's boot arguments, which would lead to boot failure. One way to satisfy install kernel is by using Draycut's config file to set the root partition unique identifier as shown below, or alternatively, for more information on what this check helps with and different ways to configure it, you can use that. So we have some new news items we need to read, so let's read the news. Most of this probably won't apply to us. Draycut crypt for encryption, host only. Yeah, we don't care about any of these things right now, so that doesn't impact us. What we will do is check our block ID here, and we'll see that VDA3 UUID is this massive value here. Okay, so what I need to do is let's try something real quick. That guys, totally forgot this is on a virtual machine. So we're gonna send a key here. What do I want to do? What do I want to do? Yeah. Yeah. So we might need to set this up here. Dang, it's been a while since I've done this. Okay, so what I'm going to do is I'm going to try and do this via copy paste in a different terminal. Let's try F2. Boom. Okay. Let's try to start up the SSH server. Start. Yay. Okay, and then we get a set a password. Uh, and I have config name A. Okay. Let's I don't want to type that long ass UUID out, so what I'm going to do is SSH into my virtual machine over here. We're going to do root at, what's this IP address? 192.168.122.237. There we go. Okay, so we're in. Password is what I said. Boom. Okay, so now we're in the live CD. So we're going to go into mount, Gentoo, Etsy. We're going to make directory dracut.conf.d. Yep. And then we're going to cd into that. And then we're going to, what do we need? We need the block ID of VDA3. Yes. This UUID here. So we're going to take this. Okay. We're going to copy this. And we're going to nano 00 install kernel.conf. And we're going to type kernel command line equals root equals. There we go. Except we don't need this, and we don't need this, and we need leading and trailing spaces here. Boom. Okay. That's done. And you notice what I did here. I don't need this key anymore. Let's go back to the main terminal here. All right, boom. I hit Control Alt F1 on my main machine, and it just like killed my entire user interface and disconnected my mic. So basically, that did not work. So when you're in a virtual machine, you don't want to do that. You want to send those keys and not hit them on your current system, because that's how it works. Anywho, nice. So now we're moving on to actually installing the kernel. Just to verify here that we created this config, dracut.d. There it is. Boom. Okay, got it? Good. Awesome. Now, what we want to do is we are not on systemd. We are not going to use a unified kernel image. We are going to use a distribution kernel. Is used to configure, automatically build, and install Linux kernel, its associated modules, yada 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 yada. So that's what we're going to use. We're going to use the Gentoo distribution kernel. We don't want to sign kernel modules, so we're going to skip that. And we're going to use Gentoo kernel. So that's what we're going to do. We're going to build a kernel with Gentoo patches from source. Do this, and that should automatically install it for us as well. So this is the Gentoo distribution kernel that we're going to install. Again, pv sys kernel Gentoo kernel. Simple enough. All right, so you can see the use flags here: harden, compress modules, sign modules, etc. We don't care about any of that right now. We're just gonna install. Boom. So this skips a major step for a lot of hardcore Linux users, where you would have to download Linux kernel sources, configure themselves, compile them yourselves, and even install them yourselves. So yeah, this will do all using Dracut, isn't it? ramfs generator, generating GRUB configuration file. We got a Gentoo theme going on. Nice, nice, nice. Okay. Done. What did that take? That alone, just installing the Gentoo kernel on a virtual machine, 10 logical CPUs, 32 gigs of RAM. Took a little over an hour, I think. About an hour. Crazy. All right. Moving on. Let's keep this truck moving. We will do the dep clean like it recommends. It's going to remove CPU ID to CPU flags for some reason. Not really sure why, but okay. Upgrade task. Since we're using a distribution kernel, we need to make sure we have that recorded in our make in the use variable here. Dist kernel. Cool. And if required, manually trigger such rebuilds by after a kernel upgrade, executing yada yada yada, and then we reconfigure. We're gonna risk it. Pretty sure since we're not upgrading, we're doing a fresh install. We don't need this. You know what? Screw it. We're gonna do it anyways. Here we go. You know, don't want to have to come back to it. So, PV module rebuild. Nope, don't need to do that. Awesome. Emerge PV config. If any kernel modules. I don't. Yeah, I don't think we need to do that. There was no modules that need to be rebuilt. So we're gonna move on to configuring the system. We are so close. So close to being done here. Love to see it. Love to see it. Okay, so next thing we're going to do is effectively set up our fstab. The fstab determines what file systems get mounted and made available at boot or at any time. It's just a general configuration file for your file systems. We used to use the paths, the file system paths to reference these systems, but these days we like to use the unique identifiers. Just makes it a whole lot easier in case things are unplugged, plugged back in, yada yada yada. You get the same drive associated with the same file system, same partition every single time. So what we're actually going to do is we're going to do this via SSH because I do not want to manually type out those UUIDs. Let's SSH back into this system. I don't think. 4. There we go. All right, so we're in the system. Keep in mind we are not chrooted in this environment here, but we want these block IDs. Okay, these block IDs, these UUIDs are what we're going to use to reference our partitions when we create the fstab, right? So first entry we're going to make is our boot entry here. We're going to use this UUID for boot. So I'm going to copy that, edit the fstab, and we're going to do the UEFI file system. This one up here. Pretty cool, right? No, that's not what I want. I need to nano. Wrong system. Mount Gentoo Etsy fstab. Here we go. We need to edit this in our home system here. So we're gonna delete this. we're going to paste that UUID. It's going to be on boot. The type is going to be vfat. The options that we want to use according to the persistent boot. Oh, we're gonna use this. We use this. Okay. Below is an example for disk format with a GPT disk label. Oh, part UUIDs. We're gonna use. We're gonna use UUIDs, not part UUIDs. Is that what we're gonna use? Hold on. Sure, we'll use part UUIDs. Why not? Alright. Delete these. Paste that. Alright, so that's boot. It's going to be a vfat file system. The options are going to be umask equals. I never used that before. Okay, time zone equals UTC. And then we're going to do 0 space 2. Cool? Cool beans? Like it. Alright, for swap, we're going to use a different UUID. We're going to use VDA2, which is our swap partition. And we're going to use this one here. And so we will drop that here. And that will be none swap 0 0. Cool. Got it. Get it. Good. Cool. Yeah, that'll work. And then for root, we're going to use VDA3, which is this one. Yeah. BTRFS. Boom. There we go, folks. That is our, this is actually BTRFS. Defaults, let's do no A time. And this one is 0 1. Yep, got it. That's it, y'all. That is our fstab. And again, I did this through SSH so I can use the clipboard to copy paste those things. Again, don't want to type those manually. That would suck. Cool. Next up, networking information. Okay, so again, remember we had to copy over our DNS resolver information. We're going to set a host name now. Let's call this Gentoo in Etsy hostname. Pretty easy there. Because we're using OpenRC and not systemd. Network section, what we need is we're going to use DHCP, the Dynamic Host Control Protocol. So we need a client for that. And that'll be net miscellaneous DHCP CD client daemon. Rock and roll. Looks like it even supports IPv6 without any extra configuration. We'll fire that off. Just one package. I don't believe this one is that big, frankly. This should be really quick. The other thing we're going to do is we're going to enable it to run by default. There we go. Pretty simple. Most packages don't take that long to compile. We're not on, so RC update, add DHCP CD default. This will make sure the DHCP service starts when the system starts up at the default run level. We won't use network manager, so we'll skip that. Configuring the network. All network information is gathered in etcconf.net. Let's go ahead and open that. etcconf.d/net. Okay, uses straightforward yet perhaps not intuitive syntax. Do not fear, everything is explained below. Fully commented example that covers many different configurations is available here. First, we need the net interface RC package. So let's get out of this. Let's emerge pv no replace net ifrc. No replace means it'll skip installing it if it's already in there. Looks like it's already in there. So here below, it'll show us how to actually configure these interfaces, right? So first we got to know what our interface actually is. Looks like this interface is called, this is local. This is your local host interface. This is the one we actually need to configure the next time we boot up, emp1 s0. So we'll go into conf.d/net and we'll just simply say emp1 s0 equals DHCP, right? Dynamically get that IP address. I don't care about anything else. Then we need to create the actual interface to start at boot. OpenRC uses init scripts. And so what we'll do is we'll basically just copy the net.lo script or link net.emp1s0 to the localhost script. And then when it gets called, it'll actually try to boot up that interface instead of localhost. Localhost will already be booted up. So now we add net.emp1s0 default. Boom. And the docs say ETH0 and not EMP1S0. That's just the name of the device on this system. That name happens to be not ETH0, but instead EMP1S0. That's how that works. So skipping system D, which we don't need any of this. Optional networking tools, we don't need dial-up, we don't need wireless. The hosts file, this is something you can configure if you have other hosts on your network and you want to be able to resolve those hosts to specific names. We're not going to touch this. We don't need to touch this. This is an isolated host on this network. We don't even want to save this buffer. So moving right along, last bits and pieces here. We're going to set a password for the root user. We're going to try that. Weak password. Yeah, I don't care. Cool. But we updated it. We don't need to change anything in rc.conf. Probably don't need to update anything in key maps. It's set to US. There's a Windows key. Cool. We don't care about that. Finally, edit hardware clock to set the clock options. Hardware clock is not, if the hardware clock is not using UTC, then it is necessary to set clock equals local. Otherwise, there might be clock skew behavior. Because we set a local time zone, I'm going to go ahead and do that to local. So that's that. System setup from a desktop stage 3 should run dbus uuidgen at this point. Dbus will automatically generate a machine ID when the package is first installed. Do we have dbus? No, we don't. We don't even have dbus. Where did this come from? Yeah, no clue where that came from. That's a little weird. Never seen that one before. Um, yeah, let me think about this for a second. Setups from a desktop stage 3. I don't think we didn't choose a desktop stage 3. We chose just a standard stage 3, so we'll skip that. System B, System D. Nope, don't need any of that. All right, we're getting near the end here, so we're gonna install a system logger. We're gonna go with defaults here. So emerge pv syslog-d. Oh, simple app. Just get that installed. We'll add that to startup at boot as well. So our system is logging. We like logging. And then we'll skip this. Wait for syslog. There we go. That's easy enough. Done. RC update. Add syslog-d default. Boom. All right. Moving right along here, we got a cron daemon. This allows you to schedule tasks to run at certain times. Pretty useful utility. Almost every system comes with one installed. I guess we'll go with the default here, cronny. It's going to pull in some dependencies. That's all right. They should be pretty small. Only 267 kilobytes in the parent package there. We also will add cronny to start at boot. So if we do have scheduled tasks on this system, they will run even after. All right. So cronny's installed. Now let's add it to boot. Oops. RC update. Add cronny default. Cool. We don't need any of these other ones. Nope, we don't care about that. We don't care about that. File system indexing. This is really handy. Usually lets you just like type locate and find a file really quick. Well, might as well install that. Sys, I always install it. I actually don't use it that often though, which is funny. I don't know why I don't use it. I'm not usually searching for files on my system. I know where they're at. All right. So file indexing installed, remote shell access. This is usually handy, so I always install SSH. It's already installed, so we'll just bake it in. Add SSHD default. And if serial console access is needed, nope, we don't need that. Shell completion. Yeah, we can install shell completion. This definitely helps. App shells bash completion. Nice. All right. Oh, let's install it. Boom. Okay. Bash completion. Okay, time synchronization. This is time servers like network time protocol. This is kind of handy. Keeps your clock in sync. Never have to worry about setting the date. So we'll get that installed. PV cronny. And install. I do this before I actually install any package because I like to see what use flags are available, what I can and cannot configure with a particular package. Sometimes something seems super interesting and I'm like, oh, why isn't that included by default? And then I find out why. Or sometimes I see something like, oh crap, it's bringing in a whole bunch of dependencies that I don't want, and it's probably this use flag right here. So I always like to peek that before I actually pull the trigger. All right. Cronny's installed. Good, good. Let's add this to boot. Add cronny default. Boom. All right. Let's see here. Checking back in real quick. Oh, I should probably check my phone. I think shit's going down. Okie dokie. Yes. All right. So cronny D is installed. It's enabled at boot. File system tools. Okay, so this is important. We have file systems on our system. We might need tools to actually be able to interact with those. So we definitely have right now is VFAT, right? So we're going to need DOS FS tools, and we have BTRFS. So we'll need BTRFS progs, and let's see what dependencies those pull in. Ah, decent amount of dependencies. Look at that. So yep. No crazy use flags here, so we're just gonna go ahead and pull the trigger on that. That's probably our biggest dependency tree we've installed. Yeah, that's 27 new packages just for some file system tools. So that's interesting. All right, 9 of 27. Roman numerals. Python Roman numerals are getting installed. Never thought you would have to install Python's Roman numerals in order to manipulate your file. All right, 13 of 27. We are so close to the end, folks. Last piece here, configuring the bootloader. Holy cow, guys. We are, what is this? 4 hours in here? 4 hours in. Yeah, these little apps are moving quick. All right. File system tools installed. Let's configure this dang bootloader, shall we? All right, so we're going with GRUB. I'm just going to skip how to select here. We already installed it, so we don't need to do that again, do we? Do we? Do we? Do we? Actually, we might have to. We need to set the GRUB platforms variable here. Just to make sure it gets configured correctly when we do install. So let's set grub platforms equals EFI 64 because that's what we're using. We're using the EFI functionality, the UEFI functionality, if you will. So we'll save this, and then we will emerge PV grub. Make sure that variable is set properly. You'll see it down here in the output, grub platforms EFI64. It's not a new flag, but we have removed PC, which is new. That's interesting. Let's do this. Let's do EFI64 and PC. And let's just double check this real quick. No changes. No changes. I think we're good. I think we're good. So EFI 64 is not a new configuration when we rebuild GRUB, so we're good to go. If it was a new configuration, we would definitely have to rebuild it. So we'll leave it as is for now. It also included PC by default. That's fine. That doesn't hurt anything long term. Yeah. So with that, just to reconfirm, we'll do ask update new use, or we can do ask update new use verbose sys boot grub. Zero packages. Sure. No. So we don't need to reinstall it. It's good to go. We do need to install GRUB on the disk though. So the UEFI system can actually load it. So we'll do grub install EFI directory equals /boot. Not EFI, because I'm a weirdo. We don't care about secure boot on this system, so we're going to skip all of that, and we are going to... Did not expect this. We need to create the grub configuration and install it. I believe the Gentoo kernel actually did this for us already. Let's double check. Boot grub. Yeah, there is a grub.config. Interesting. This setup is saying we need to install it in /EFI. Boot EFI. No. What's in env.d99? There is no envd.99. And grub config is already installed. So let's check it out. So here it is. Here's the menu entry that will load up our Linux system. I'm gonna risk it, and I'm gonna skip it. We're gonna skip this step. I think it's already configured. We don't have to skip it. We can do this the way I normally do with boot grub.config. You notice when we installed the Linux kernel, it already created that. But this is what it would look like if you did run it. I don't use this path for some reason. I don't know why they're telling us to use this path. Must have something to do with... Oh, here. When you're using secure boot with UEFI, you use that path. So the normal path, the normal command is the one I just ran here. We're not going to use systemd boot. We're not going to use secure boot there. We're not going to use the EFI stub. We're not using a unified kernel image. So we're good. We're done. We are ready to reboot this system. So let us exit cd unmount mount gentoo /dev shm pts and those, and we'll unmount recursively mount Gentoo, and we'll reboot. Here we go, guys. Are you ready? Are you ready to boot into your Gentoo Linux system? I am. Gosh, it's been like 4 hours. There it is. Grub is working. The Gentoo Linux install is being detected, at least as a menu option. Hopefully this boots. It's loading the RAM disk. It is booting up the system. We are in OpenRC. It is loading everything up. Check, check. 1, 2, 1, 2, check, check. And we're in. Boom, boom. This is Gentoo, folks. Just like you would land in your very first install of Arch Linux, we are now in Gentoo with our new system here. Let's see if networking works. It does. Yay. So we have networking. We have a Gentoo system. We are ready to rock and roll and continue from here. So the very last thing I'll do is I'll create a user. We'll give them a home directory. We'll add them to the users group. We'll add them to the wheel group. We'll add them to the audio group. If there is an audio, if you're ever wondering what groups are available, you can cat etc group. Group, see all the groups available. Don't need most of these groups for your typical user. In fact, I recommend minimizing the number of groups your user is actually in. But we definitely want to give them a home directory. That's what -m does. We definitely want to add them to users. Is that a, yeah, that's a group. We want to add them to wheel. We'll use that later for sudo. Let's add them to video, USB. Is there an audio group? There's an audio. I thought I saw an audio group. Did I see an audio group? Maybe not. Maybe not. Well, I'll show you after this how to add users to a group. Their shell, we're going to make them use bin bash, and the username will be Matt. Boom. User added. Now, if we want to say cat etc group and grep for audio, there's an audio group. Okay. I couldn't find it for some reason. Maybe I'm going blind. But if you wanted to add a user to a group after the fact, just group password add Matt audio. Adding user Matt to audio group. Cool. We should set a password for Matt. The Matt's new password will be this. Boom. Password updated successfully. Now I can exit. I can log in as Matt with my password. If I type the right password. Boom. Now I'm in. Cool beans. This is interesting. Where am I? I'm in home Matt. Failed to start user.mat. This is a new error I've been seeing lately, and I'm not exactly sure why I'm getting this error. So we'll dig into that. And actually, you know what? Error user dot failed to start on Gentoo. Oh, dbus? Do we gotta add dbus? Is that the problem here? Let's check out dbus. RC update add dbus. I don't even think we have dbus installed. Sys apps dbus, a message bus system, yada 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 yada. This is typically used by a bunch of different applications actually. So I'm gonna install it. Why not? Okay. Yep, that's good. That's good. There we go. Moving right along here. Okay. Compiling. We're gonna ditch this for now. We don't need that anymore. We'll get this cleaned up a little bit. We'll get our user fully functional, and then we'll wrap up. And then in the next stream, what we'll do is we'll start building out our user interface a little bit further. So let's see here, update add dbus default. Yeah. Okay, so RC service dbus start. There we go, dbus is running. Now, if I log in as Matt, does that work? That works! Yay! Okay, we're in, no errors, super cool. I don't even have sudo installed. Do I have nano installed? I do have nano installed. Let's get sudo installed. So we can sudo our way around this system. Oh, no, that's not what I wanted. Root sudo. Cool beans. All right. So we'll get sudo installed. I don't see any extra use flags that I need, so we'll just install that. 6 packages here. Not too big. Sudo is a little larger, so that might take a second. All right. Oops. And let's check. All right. That's installed. So one thing I like to do is update this configuration here that basically allows users in the wheel group to use sudo without having to enter their password. So obviously root can use sudo. We want wheel to be able to use sudo without a password. So we'll save this and we'll log in as Matt to prove a point here. If I can type the password correctly. No, I still can't type the password correctly. Let's try this. There we go. All right, so now I can sudo ls la root, and boom, I can look at root. So that's sudo. That's this system completely installed. If you want to see the kernel we have installed here, it's Gentoo 6.18.25 distribution kernel. It's preempt dynamic. We'll get into that later, maybe. Maybe not. Who knows? But where do we go from here? Well, you probably want a user interface. You probably want Windows. You probably want some graphical login. You probably want a fancier boot up that has some cool graphics and all that jazz. We'll dive into all of that in future sessions. But at this point, folks, we are effectively set up to, start building out our system. The Gentoo is installed, it's running, it's working. We have users. We have a basic set of apps and utilities we can use to navigate the system and continue to build on top of it. So for a send-off, we're going to try installing a fun program called CMatrix for some cool graphical visual funsies. So we just did that via sudo from our user. Source is compiled. It's all installed. And we're ready to go. Are you guys ready? Are you guys ready for this craziness? We're in the matrix now! Okay, well, hope you guys enjoyed that. We'll be back with more. Continue to build out this Linux system to be a beautiful Gentoo system that everybody can learn to love, and maybe if you're following along on this journey, you're inspired to install Gentoo for yourself. Or at least try out another Linux distribution, right? If you're hanging out over on Ubuntu or Linux Mint, and this was a little overwhelming, maybe you can try Arch. In the last stream, I installed Arch and got a user interface, graphical interface set up in only a couple minutes. It was, some command line and manipulating of network configuration in order to get that thing stood up. So it wasn't, as easy as installing Linux Mint or Ubuntu or, Pop OS or something like that. But far, far quicker and easier than Gentoo. But that gets you, again, set up with a base system that you can start to build on top of. So we'll be back in another stream later, basically demonstrating how to continue from here and get yourself to a great workable state with all the fun tools and apps that make Linux just a blast to play around with and do all your work in, frankly. So, with that, folks, I really appreciate everybody who tuned in today. I am going to peace out and go make some steak because your guy's hungry. So, thank you, everybody, for tuning in. Appreciate y'all. We'll be back real soon. Peace out.